Welcome to G Fun Facts Online, where we dive into the coolest science shaping our future. Today, we're talking about something straight out of a sci-fi movie. Machines that can see like us, but without guzzling tons of power. You know, artificial intelligence is getting amazing at recognizing images and videos. Think self-driving cars navigating busy streets, or AI helping doctors spot diseases. But there's a catch. These super smart vision systems are incredibly power-hungry. They need massive amounts of energy, storage, and computing power. This is a huge problem, especially for small gadgets like your smartphone, drones, or those tiny sensors in the Internet of Things. What if we could make these vision systems super efficient, maybe even power themselves? Get ready, because we're exploring the world of self-powered artificial synapses. So where do we look for inspiration to build such efficient systems? Nature, of course, specifically the human brain. Our brains are masters of efficiency. Your brain, right now, is processing everything you see, hear, and think, all while running on about 20 watts of power, less than an old light bulb. Our eyes and brain don't process every single tiny detail. Instead, they selectively filter information. The secret lies in neurons and the connections between them, called synapses. These synapses aren't just wires. They actively change how signals flow, which is key to learning and memory. This biological brilliance has sparked a field called neuromorphic engineering, basically building computers that think like brains. This brings us to artificial synapses. These are tiny electronic devices that mimic our biological synapses. They can get stronger or weaker over time, depending on the signals they receive, a process called synaptic plasticity. This learning ability makes them perfect for building artificial neural networks directly into hardware, allowing devices to learn and make decisions on their own, without constantly sending data back and forth to a central processor, which is a major energy drain in traditional computers. Now, let's take it up a notch. Self-powered artificial synapses. Imagine these brain-like connections, but they also generate their own electricity. These devices can harvest energy from their surroundings, like light or movement, to power themselves. This means they could work almost indefinitely without needing batteries or to be plugged in. How cool is that? Scientists are using clever tricks, like the photovoltaic effect, where materials convert light into electricity, perfect for vision systems. Or they use turboelectric nanogenerators, or TENGs, which turn mechanical energy like vibrations or touch into power. Piezoelectric materials, which generate electricity from mechanical stress, are another option. So how do these self-powered wonders help machines see better with less energy? By combining energy harvesting and synaptic functions in one tiny package. For example, researchers at Tokyo University of Science have created a self-powered artificial synapse that can recognize colors with nearly human precision. It uses two types of dye-sensitized solar cells. These cells not only tell different colors apart with incredible detail, down to a 10-nanometer resolution, but they also generate their own power from light. This single device can even perform complex logic operations that would normally need multiple components. Other cool materials like perovskites, which are great at absorbing light, and super-thin 2D materials like graphene, are also showing huge promise for building these self-powered vision chips. They process visual info right where they see it, a concept called in-memory computing, slashing energy use by not having to send tons of data around. And the progress is staggering. We're seeing devices achieve near-human color recognition. That Tokyo University team also showed their single self-powered synapse could classify 18 different combinations of colors and movements with 82% accuracy, a task that would typically need a whole bunch of sensors. Some of these artificial synapses use incredibly tiny amounts of energy, measured in femtojoules, which is similar to, or even less than, our own brain's synapses. They're not just sensing and processing, they're also performing logic operations like AND, OR, and XOR, all powered by light. They're even starting to mimic complex brain behaviors, like how we learn new things, or even how our pain receptors work, all under their own power. What does this mean for us? The applications are mind-blowing. Think about edge computing and the Internet of Things, smart sensors in your home, city, or out in nature, seeing and reacting to the world for years without a battery change. Autonomous vehicles could become safer and more energy efficient. In healthcare, Imagine wearables that constantly monitor your health using vision, or tiny diagnostic tools that don't need bulky batteries. Robots could perceive and interact with their environments more intelligently and for longer periods, even in remote places. Your smartphone or AR headset could have amazing visual features with way longer battery life. Even agriculture could benefit, with low-power drones monitoring crop health. The advantages are undeniable. We're talking about a massive reduction in energy consumption for AI, making it greener and more accessible. Faster visual processing because data is handled locally. Smaller, more versatile smart devices because everything is integrated. And systems that perform more like our own sophisticated brains, with much longer operational lifetimes, especially for battery-powered gadgets. Of course, it's not all smooth sailing. There are challenges. Making these devices on a large scale, affordably, is tough. The new materials need to be durable and stable. Integrating them with current technology is complex. We also need new algorithms designed specifically for this hardware. And while we're making huge strides, fully replicating the human brain's visual prowess is still a long way off. But despite the hurdles, self-powered artificial synapses are paving the way for a revolution in machine vision. They combine materials, science, neuroscience, and AI to make machines that see intelligently and sustainably. We're getting closer to a world where our smart devices can perceive their surroundings with human-like sharpness, all while barely sipping energy, or even better, powering themselves. The journey is ongoing, but a future with truly low-energy, intelligent machine vision is an exciting one to watch. Thanks for tuning in to G Fun Facts Online.